All right, this next theorem that we're going to look at is called the mean value theorem. And what it does is if you have a function like this, it finds the average area. So maybe like this. This would be the average area, this blue rectangle. And this average area would be the same as the area under the curve. And what the theorem actually says is if you integrate from a to b of the function, that would be this black curve right here would be the function of f of x dx, that has to be equal to some rectangle, this blue. Well, this rectangle itself, right here, has a width of b minus a, because here's a, here's b, times the height of the rectangle. Well, the height of the rectangle, one point on the height of the rectangle would have to be where the rectangle meets the function, so we multiply that times the function evaluated at c, is what we're going to call that. So what you have to be able to do with that is, let's say you have this function f of x equals 9 over x cubed, and you're going to find the area between 1 and 3. Okay, so I'm going to integrate. So if I integrate between 1 and 3 of 9 over x cubed dx, when I integrate that, I end up with negative 9 over 2x squared. And then I use the fundamental theorem of calculus, and I put in 1 and 3. So I put in 3 first, because that's what I do with the fundamental theorem. I put 3 in first, and then I put in 1, and that gives me 4, if you calculate that. So what I'm going to do is show you that the mean value theorem has to hold true. That 4 has to equal b minus a times the function evaluated at some c. So I'm just going to use c cubed here. Well, b minus a is, 4 equals, b minus a. So 4 equals b minus a, so 3 minus 1, times my function at some number c. So then you just do some algebra, and you get 4 equals 18 over c cubed. So c cubed equals, or 4c cubed equals 18. So c cubed would equal 9 halves. And then you take the cube root of 9 halves, and that is where the height of the rectangle would be. So the square root of 9 halves, it's the square root of 4.5, so it's somewhere between about right after 2. So if you graph your function, this function itself at 1 is at 9, so it's up here, and at 3 is at like 1/3 way down here. So here's 1 and here's 3, and so this function looks like this, and the area would be under here. Well, the average, or the mean value theorem says then that at about 2.1, we'll say, is the rectangle right here that represents the same amount of area. And really what your job will be is to find this c value. So you have to integrate and then set it equal to b minus a times the function evaluated with c, and solve for c. Now something else that goes with that is called the average value theorem. And it's very easy. All you have to do for the average value theorem is you integrate to find your area. And then to find the average, you take your area and you multiply it by 1 over b minus a, or basically divide it by the width, right? The length between b and a. So if I have this function, f of x equals 3x squared minus 2x on the interval between 1 and 4, to find the normal area, I would integrate from 1 to 4 of 3x squared minus 2x dx. And when I do that, I get x cubed minus x squared. And I integrate that between 1 and 4. And when I do that, I get 48. So I have this function who, between 1 and 4, so if I look at this at 1, I get 1. And at 4, This function would be at 40, so it's way up here. And it's a parabola that looks like this. So that's the area, but to find the average area, I take the 48 and I multiply that by 1 over 4 minus 1, or 1 over 3, which is 16. So 16 is your average area. So between each block is 16, and that's the average value theorem.